Today's lesson is on section 7.6, solving systems of linear inequalities. We've recently been solving linear systems of equations all the rest of this chapter, but this last section in chapter 7 talks about solving linear inequalities. Remember, what are inequalities? Well, we're talking about the signs like less than, greater than, less than or equal to, or greater than or equal to. And graphing linear inequalities actually is going to seem very familiar. At the very end of chapter 6, we did this same thing, but we didn't have systems. So now we're going to graph linear systems of inequalities where we have two or more. So here's a linear system of equations. And again, we've talked about linear systems of equations. What are we looking for? What are the solutions for a linear system of equations? Well, there's possibly just one solution where the two lines cross, or there can be possibly no solutions, or we can have an infinite amount of solutions. Those are our three options. If we're talking about inequalities, remember inequalities in general, there are often many solutions for each inequality. And I'm actually going to show you here that these are also two inequalities that I have up here, showing that there was a system of equations, but now let's look at it as a system of inequalities like we're going to solve today. Again, what we're looking for then, what are the solutions that we're trying to find, are the solutions that fit both of these two inequalities. Now, the way that we talked about showing all the solutions for an inequality in two variables at the end of chapter 6 was by graphing, and that's going to be the best way to solve these systems as well. So let's look at that top inequality, 3x plus 4y is greater than 12. What I'm going to do is I'm going to graph that inequality, and maybe we'll remember some of those steps from the end of chapter 6. But I'm going to graph that. That's going to show me all my possible solutions for that inequality. The best way to graph this one right now is it is in standard form, so I can find my x and y intercepts. And using those, I'll be able to make a nice graph. If I put in 0 for x, again, that's like canceling out this term, really. And then solving for y, I'd get y is equal to 3 if it was an equation. So if I put in 0, I get 3 for y. That's my y-intercept. If I put in 0 for y, and divide 12 by 3, I get 4. So that's my x-intercept, 4, 0. Again, I can plot those 2 points, 0, 3, 4, 0. And now remember, when we were graphing inequalities, there was some more information here we can get from the actual inequality itself. Because this is a greater than sign, that means that this will be a dashed line. That line means my line is the boundary for the inequality, but it's not going to be part of the solutions. So through my 2 points, I'm going to draw a dashed line. There's the graph of this inequality so far. At least there's my line that I should have. Now remember, for any inequality as well, like we did in chapter 6, all the solutions then for this inequality are really either on one side of the line or the other. And how do we check that? Well, we plug in a point like 0, 0. Let's take the origin here. That's usually a very easy point to plug in. I'm going to plug that into this inequality, and we're going to see what we get, if we get that 0, 0 as a solution or not. So if I put in 0, 0, I get 0 plus 0, which is just 0. So I'm going to get 0 on the left side. And I'm asking, is that greater than 12? Well, no, it's not. So 0, 0 is not one of the solutions down here in this grid. So then for this inequality, that means that all the solutions must be on the other side of this line. So here's where all the solutions are for that inequality. Again, so far, this should look like a review of chapter 6. We did this right at the end when we were graphing linear inequalities with two variables at the very end of chapter 6. But now we're talking about a system. So now we're also interested in what the solutions are for this inequality as well. And where the two inequalities solutions overlap, that's what we're looking for the solutions for this system of any inequalities. So if I look at this red one now, this one I'm going to graph as well. This one's in slope-intercept form, which is nice. The slope is 1. The y-intercept is 3. So I can go up to 3 on the y-axis and put a point, and then go up 1 over 1, up 1 over 1. And I can find more points, even go in this other direction too, by going down 1, left 1. But I can make all my points. This type of inequality is going to be a solid line, because in this case I have the less than or equal to sign. Because it's got that line underneath and it says it can be equal to, that means I'm going to have a solid line. That means the line is part of the solutions for the inequality as well. Any point on that line is also a solution to this inequality. And then I can check a point like 0, 0 and see which side I should shade on. But if my equation's in slope-intercept form like this one is, remember also, just by looking at the inequality itself, we can tell if we should shade above the line or below. Since this inequality right here is less than or equal to, remember that actually meant in slope-intercept form, then all the points are less than, all the solutions are less than the line or below the line. So actually in this case, I know I can just shade underneath. I could check 0, 0 as well, and I would find that that would be a solution. But also when they're in slope-intercept form, I can just look at the inequality and tell which kind of case it's going to be. Then, so now I've shaded all the solutions for the blue inequality, all the solutions for the red inequality. What I'm looking for, though, are the solutions to this entire system. And the solutions to the entire system are the solutions that fit both of these inequalities. So where is that? And usually if I ask the class, after a little bit of thinking, we can figure out it's going to be this section right here where I've shaded in red and in blue. So I can maybe outline that a little more. If you're doing these in your homework, maybe you could shade that just a little darker with your pencil. Shade everything kind of light, the first two inequalities lightly. And then when you're finding the solutions for the entire system, then shade it in nice and dark. There's where all my solutions are for the system. So what are we saying with all these points? Okay, we're shading in all the possible solutions for this system. Well, that means that if I take some random point, like let's say, if I look for a point, let's say 8, 2, okay? 8, 2 would be a point right here. I've kind of made it in green if you can see that. There's where the point 8, 2 would be. It's in my doubly shaded region where it's shaded in red and blue. That means it should be a solution to the system. If it's a solution to this system, it should work in both this inequality and that inequality. And so let's check that. I'll bring it down here for the top one. If I put 8 in for x and 2 in for y, 8 times 3 would be 24. 2 times 4 would be 8, not 16, but 8. And is that greater than 12? Well, yes, I think 24 plus 8 is 32. Yeah, that is greater than 12. So that 0.82 works on the first inequality. Bring down the second inequality. If I put 2 in for y and say that's less than or equal to 8 plus 3, well, 8 plus 3 is 11. And yeah, that would be bigger than 2. So yes, it works for the second one as well. So yes, just showing this is a solution to that system because it works for both of them. It's in that shaded region of the overlap. We'll do just one more example here together and show a system where maybe there's even 3 inequalities. There could be 3, there could be 4, you never know. In this case, there's 3 inequalities we have to graph and try to find the solution for this system of inequalities, all 3 of these together. So first of all, starting with that top one, negative 6x minus 15y is less than or equal to 30. This one, again, would be a good one to graph using intercepts method. I would put in 0 for x and 0 for y and see what my intercepts are going to be. And again, if you don't remember that method, that is a very handy one. So I would try to recall that one because, as you're seeing, it can be useful still, even in this chapter. If I put in 0 for x, 30 divided by negative 15 would give me negative 2. So my y-intercept would be negative 2. Going back to the original inequality, if I put in 0 for y, 30 divided by negative 6 would be negative 5. So there are my 2 intercepts for this particular inequality. 0, negative 2 would be down here. Negative 5, 0 would be to the left 5, up and down 0. This line in this case should be a solid line because it does have that line underneath. So a solid line, that means the line is part of the solutions. Any point on this line is also a solution to this inequality. And the rest of the solutions are either above or below the line. So again, we'll check 0, 0. See if the origin works, and if it does, then all the solutions are above. If it doesn't, all the solutions are below. So we're going to check this point right here. If I put in 0 for x, I get 0. Put in 0 for 15, I also get 0. So what I'm trying to determine is 0 less than or equal to 30? And yeah, I think that 0 is less than 30, so yeah, I think that's going to work in this case. So 0, 0 must be a solution. So that means I'm going to shade on the side with 0, 0, which means I'm going to shade above in this case. So there's where all the solutions for this inequality lie. Any of those points that are shaded in would work in that first inequality, the blue one. Going on to this next one, I'll do in green. This one's in slope-intercept form again. So I can pick out the slope, which is 3/4. I can pick out the y-intercept, which is negative 1. Negative 1's my y-intercept. I'll start there. Then I'll go up 3 over 4. And put a point. Up 3 and over 4 again. And put a point. This one, also I can look at my inequality, and I'll see that's going to be a solid line as well. So this one, again, the line is also part of the solutions Any point on that line would be a solution to that inequality. And again, for these, when they're in slope-intercept form, I can just look at it and say, well, the inequality is less than. So that means I'm going to shade below the line. So all the solutions for this inequality are below the line. So now, so far, I've got an overlapping area over here, but I'm not quite done. I do have one inequality left I'm going to have to consider and then determine all my solutions for this system. I've got this last one here. Y is less than 1. Now, this last one doesn't have two variables, but we have graphed things like this in the past. Think about an equation where it says like y equals 1. Well, where is y equals 1 on the grid? Well, here's the y-axis. So if I just go up 1, there's where y equals 1, and it's actually anywhere along that horizontal plane. So in this case, all my points are going to be where y is 1, so that's where I've gone up 1 anywhere. And maybe some will remember that too. It's just that horizontal line, that case. My line in this case is going to be a dashed line, because I see that it's just less than. It's not less than or equal to, so it's just less than. So I'm going to have a dashed line at y is less than 1. And since I want less than, again, just because it is slope-intercept form, it does have y by itself. I want all the y values that are less than the line. So in this case, again, I'd be shading everything below the line. Again, when you're doing this in your homework, I would just shade very lightly for all the first three inequalities, and then when you have to combine them, then that's when we'll shade a little darker. So where is the overlap in this case? Where are the solutions to this system? Well, I need to be below the red line, above the blue, and below the green. So where is that? Where does that happen? Well, I do see a section right here, below the green still, above the blue, and at the same time still below the red line. All the solutions to this system are right in this little chunk right here, this area in the black. Again, sometimes as I tell people in class too, I like to think of solving linear inequalities like a process of elimination. We're eliminating all the possible things that aren't answers. And so what are we left with? Well, then all this area must be the solutions to the system. Any point that lies in there is a solution to this system of inequalities. Again, I could pick one out and check. Let's say I pick out the point somewhere in here. Let's say I know there's a point 3, -2. I bet you is in here somewhere. We're buried deep in there is the point 3, right 3 and down 2. So if I pick out that point and I try to plug it into every one of them, well, I'll plug it into this one first. -2. I just plug in the y-coordinate. Is that less than 1? Yes, it is. So, yep, 3, -2 works in this inequality. If I plug it in the next one, if I plug in 3 for x, I'll get 9/4. And 9/4 is about 2, 2 1/4. -1 would be 1 1/4. And what I'm trying to determine is for y, let's see, is 1 1/4 greater than -2? Well, yes, it is. So, yep, it works for the second inequality as well. And then just checking the last one. 3 times -6 would give me -18. -2 times 15 would give me +30. And so what I get there, I get 12. Is 12 less than or equal to 30? Yes, it is. So yes, it also works for that inequality. So notice, again, any point that I would pick in that black area would work for all three inequalities because that's the solutions to our system. That's what we're trying to find, the area that would work for the area that's overlapped by all inequalities when we graph them, because that's the solutions to the entire system.